Hello, classmates. I'm Chen Huixun from Guangxi Financial Vocational College. I want to discuss with you today a very common phenomenon in life. In the field of sports and fitness, we often focus on these two indicators, body weight and body fat percentage. Have you ever thought about changes in weight and body fat percentage? What is the connection between them? From experience, it seems that when you gain weight, body fat percentage is also on the rise, but not absolutely. For example, through fitness exercise, increased muscle mass may cause weight gain, but body fat percentage is declining. Weight and body fat percentage. What kind of relationship is there? Don't worry, everyone, we will answer this question in today's lesson. Actually, between weight and body fat percentage, not like the side length and area of a square. The side chief is confirmed. The area has a uniquely deterministic functional relationship. It's a kind of non-deterministic quantitative dependence. This relationship is found in statistics. We call this a correlation. From a statistical perspective, everything in the world, between objective phenomena and objective phenomena, they are universally interconnected and interdependent. There are two relationships. One is a functional relationship. The other is a correlation. The difference between the two is that a functional relationship is a completely deterministic relationship. For example, area of a square must be equal to the side length multiplied by the side length. The area of a circle must be equal to the square of pi r. Correlation means there is no completely deterministic relationship. It cannot be valued by one or more variables. Find the exact value of another variable. For example, you can use your weight to accurately calculate the value of body fat percentage. You can only estimate the value of body fat percentage. We define the concept of relatedness. So we're thinking, what are the kinds of relationships? First, according to the degree of correlation, it can be divided into perfect correlation, imperfect correlation, and no correlation. First, there is perfect correlation. Go to the fruit store to buy fruit. Put the fruit on the scale. As the variable of fruit weight changes, the variable of price will also change accordingly. And as long as you know the unit price of the fruit, given any weight, the price of the fruit can be calculated using a fixed formula. This is the functional relationship just mentioned. That's a special relationship, perfectly correlated. True is imperfectly correlated. When weight changes, body fat percentage also has a corresponding change trend, but not strictly exact. This is imperfect correlation. The third is irrelevant. Know the height of a classmate. It's hard to speculate on his math grades from this. Height and math scores just don't correlate. In addition, the relevant relationship is in the relevant direction. It can also be divided into positive and negative correlations. Positive correlation with weight gain. Body fat percentage goes up. You lost weight. Body fat percentage goes down. It's a positive correlation. The second is a negative correlation. The more you smoke, the worse the health. The less you smoke, the better your health. It's called a negative correlation. Alright, we have learned about the types of correlations. For example, know the difference between weight and body fat percentage. There is a positive correlation outside the relationship. We might want to know more. How strong is the correlation between body weight and body fat percentage? Can it be determined by a person's weight to roughly estimate his body fat percentage? Don't worry, everyone. There are two ways to solve these problems. First, correlation analysis. This method can be measured. What is the correlation between body weight and body fat percentage? 3-view analysis. It is by calculating the index of correlation analysis coefficient R to measure weight, the degree of correlation with body fat percentage. If you can calculate weight and body fat percentage, the absolute value of R is less than 0.3. It's not relevant. If the absolute value of R is greater than or equal to 0.3, less than 0.5 indicates a low correlation. If the absolute value of L is greater than or equal to 0.5, less than 0.8 indicates a significant correlation. The absolute value of L is greater than or equal to 0.8, indicates high correlation. L greater than 0 is positively correlated. The phenomenon of less than 0 is negatively correlated. So correlation analysis, by calculating the correlation coefficient R. So we know how relevant the variables are. And can also know the direction of correlation between variables, positive or negative correlation. Solve the first problem. That second question, can you estimate body fat percentage by weight? This problem requires regression analysis to solve. Regression analysis is simple. It is the study of one or more independent variables, the method of relating to the dependent variable. Through it we can build mathematical models between independent and dependent variables, and then we use that model to make predictions. For example, we take body weight as the independent variable, body fat percentage as a dependent variable. We developed a linear regression model. We will get a regression straight line. According to this straight line, roughly predict body fat percentage by weight.
Y equals A plus BX.
Finally, let's review the content of this section together. Between objective phenomena, there are functional relationships and correlations. Correlation can be determined according to the degree of correlation, relevant direction to classify. Correlation analysis can be used to find out how correlated the variables are, and can know the direction of correlation between variables. Predict the estimated value of the dependent variable for regression analysis. Actually, we find that statistics is a very interesting course. For example, the mathematical romance of functional relationships. You give me a definite input. I will return you a certain output. There are also related analyses, like detectives exploring hidden connections between variables, remind us, with a more scientific perspective, to see the relationship between things. Positive correlation time, a variable increases, and the other one goes up. A variable becomes larger. Another decreases. It's like a human relationship. They interact with each other, they relate to each other. Remind us to learn to empathize in life. Understand the position and situation of others. With tolerance and understanding, build a harmonious relationship. After class, please make use of the knowledge in this class to unearth true objective phenomena that are related, and collect data separately, such as study duration and academic performance, weight and body fat percentage, etc. Calculate for our next lesson. Accumulated cases of correlation. The above is all the content of this lesson. Thank you very much.